Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to take a look at FMEA, failure mode and effects analysis. And in particular, we're going to take a look how to fill out an FMEA, a process FMEA, by the way. So this is specifically a process FMEA, and we're going to look at how to fill out an FMEA properly, how to do it fast, and how to do it to make money, because that's what an FMEA does. It makes money. And to be quite honest, the FMEA, I'm into Six Sigma and I teach people how to solve problems. A lot of the time, I'm not using FMEA to do that. If the FMEA, the process FMEA, is used correctly at the beginning of the cycle, Six Sigma would never exist. Six Sigma is not needed if an FMEA is done correctly. So we're going to take a look at a process. We're going to take a look at a process FMEA. So some people like to put a P in front of this thing, PFMEA. The reason why I picked this subject, one of my clients is implementing a new manufacturing process. So they are not going to use the traditional Six Sigma problem solving type techniques because they don't have a problem yet. They are going to use FMEA, and they sent me this document. So this is telling me that there is a new guideline now for the AIAG FMEA process. This thing sort of tells you the benefits. It doesn't tell you exactly how they're going to do it, but the benefits in this document, one of the things they talk about is the fact that the new methodology, and it says here it's a more structured approach, it leverages lessons learned, so it's building on control techniques that you've already got, I guess. But here's the one I'm really interested in. It is error proofing driven. It is error proofing driven. Now what that's basically saying is this is more about prevention than detection, and that's really what a great FMEA should drive you towards, prevention rather than detection. So let's just set the context up first of all. FMEA. Now an FMEA, in a real sense, is basically a risk assessment. So if you haven't done one before, if you haven't done an FMEA before, and by the way, most people hate FMEAs. They're normally slow, sluggish, soak up lots of time. People just fill them in to keep customers happy and keep ISO auditors happy, but they never use them. They're a complete waste of time, most FMEAs. Think about your company. Is your FMEA valuable? That's what we want, a valuable FMEA. So it's basically a risk assessment. Now, what is risk made up of? Well, it's made up of the severity of the error that you're likely to make. It's made up of the likelihood, and I think that's how you spell likelihood. Yeah, likelihood. Not sure. The likelihood that it's going to happen. And finally, most FMEAs talk about the detection controls. How likely are you to spot the error? And if you multiply the severity by the likelihood by the detection controls, you work out what's the risk. Okay, so if it was a health and safety risk assessment, what's the risk that you're going to have an accident, that you're going to kill somebody, that the unit is going to fail and cause a severe problem? What's the risk? Now, of course, in a process FMEA, what's the risk? Well, typically, the risk is pretty straightforward. The risk is defects. Take that one stage further. If you let those defects out of your company, the risk is dissatisfied customers. And what will dissatisfied customers cost you? if you let them exist, dissatisfied customers can cost you your business. That's what the risk is. Now, if you use an FMEA properly, if you use a process FMEA properly, and this is what I've advised my client to do, he has a new process. What I'm going to get him to do is design the process. You are going to design the process into the FMEA form. We are going to design the process straight into the FMEA form, and what's going to come out of the FMEA is a control plan, and then when you switch the process on, bang, it's right first time. That's the power of a process FMEA. You can make more money faster, make good products faster. You can go live defect free. That's what it's for. It's to design a process. So let's take a look at the traditional FMEA form, and then we'll talk about the importance of filling it out. So here is the basic FMEA form. So on the left hand side, look, you can see we're going to design a process. It says what's the process step. All right, so let me just show you a product that maybe we're going to use as a little example. So let me just show you a product. So here's the product that we're going to use as our little FMEA example. So imagine you're setting up a production line to make a remote control for a television. Okay, so you've obviously got to make the electronics, you've got to mold the front, you've got to mold the back, you've got to mold the battery cover, you've maybe got to mold the rubber buttons, then you've got to assemble the whole thing, and then it's got to work. Okay, so that's the product that we are going to design the process for. In actual fact, I'm probably just going to talk about the battery cover just to keep this simple, but you will see the procedure on the form. So we're going to use this as a little example, and then we can design it into the form. Okay, so process step. Now then, this has got to be in detail. So something to avoid in the process step. We don't just want to say something like mold battery cover. All right, so we could just put mold battery cover. Now, there's not enough detail in that. What you have to do is talk about, okay, we're going to make the battery cover. So step one is maybe, I don't know, maybe you're going to weigh out material. So maybe you're going to weigh out how much plastic you want. Next step, you're going to dry material. Feed to molding machine. So we're going to blow it into the top of the molding machine. Feed to the molding machine. Then we're going to heat in the barrel. Then we're going to inject to tooling. I don't know, we might talk about the cooling time. Eject from tool, and then maybe packing boxes. Yeah, so you can see the detail that's needed. Okay, you can see the detail that's needed. Now if you look at that, what am I doing? Well, I'm effectively designing the process. Obviously for a molding process, it's a fairly generic thing. So whatever molding activity I do, those, and how many lines have I got? Those 8 lines could be standard every time I do this. And this whole FMEA could be standard every time I do a molding activity. but you can see there's some detail. I've designed the process. Now, if this was an assembly production line, of course, this would be more of a design function. It might be more unique to making that remote control as opposed to actually assembling the TV, which again would be a completely different FMEA, and you'd have to think uniquely. You have a new product with a new design, a new rear cover, and maybe a new way of fixing the rear cover, etc. So the FMEA would be more unique for a more unique product. But for molding, what we're looking at here could be very, very generic. Okay, let's go back to the form. Now the next box here, this box here, I'm going to color this thing in. Let's color this thing in red here, because this is super important. What is critical to quality? What is critical to quality about this step? So I'm just going to pick the drying of the material. So we could say it's the moisture content. Okay, I would prefer to do it like this maybe, and I'm going to call it drying time. So drying time is crucial. What is critical to quality about this step? Drying time is crucial. Okay, so what you've done is you put your thoughts down now. You've designed the process. You are saying which parameters are crucial to the quality of the product. Okay, let's go on. Let's go to the next box. Now it says, what's the failure mode? Now let me change something in the failure mode, because this is how can the input fail? So this is an input failure. So in other words, how could the drying time go wrong? What could go wrong with the drying time? What could go wrong with the item that's critical to quality? What could go wrong with the input to the process? Because drying time is an input. So if we go, I'm going to say drying time is too short. There is the failure mode. Then we say, what's the failure effect? Now the failure effect, let's put the output. This is the output failure. So you can see we've got two failure modes. The failure mode, how does the input go wrong? The failure effect, how does the output go wrong? Now if you get these mixed up, this is where FMEAs start to go completely to pieces, because if you put the wrong thing in the wrong box here, so under the output failure, let me just enter something in the output box a second. We'll come back to this now. So I'm going to get white marks in the molding. And then maybe in brackets, high scrap. Okay, so I've got white molding. I've got white marks now in the plastic, and a high scrap rate. Now, if I put that in the wrong box, if I say the failure mode is that I'm going to get white marks in the molding, then I say, what's the failure effect? Now you're having to think forward. You're having to say, well, there's going to be a high scrap rate. Maybe we're going to be late with the customer because we haven't got enough parts. Maybe we're going to delay an order to a big customer. Maybe we're going to lose a big order. Now you have to guess, because you put the failure effect in the wrong box. You put the failure effect in the input box. No. Drying time is critical to quality. What could go wrong with drying time? The drying time is too short. What effect will that have on the process? A high defect rate due to white marks in the molding. That is the proper way to do it. Inputs and outputs. There is the Six Sigma principle, loud and clear in the FMEA. And by the way, that was always there. 20 years before Six Sigma ever existed, FMEA was floating about, and inputs and outputs were always there. People just were never told how to do this. But you have to get the input in the right box, the output in the right box. Let's go back to the form. Now what we're going to do is we're going to give this failure effect a severity score. Now this is often from 1 to 10. Now the piece of advice here with the severity score is that you write your own table describing how painful this problem is. So I'm going to show you some text from my book called Drink Tea and Read the Paper. Here is a severity table. This is actually for products rather than for processes, but I use it because it's from the car industry, but it tries to be nice and specific. So they try to describe ranking 10. So look, ranking 10, when the potential fail mode affects the safety of the vehicle, you know, and the problem could happen without warning. So you're going to get a problem without warning. It could be a safety related problem. So in other words, you could injure or kill somebody and the failure will happen without warning. That's a 10. If you go down to an 8, look, it says the vehicle or the item is inoperable with a loss of primary function. So they're trying to be nice and specific so that selecting a score, so go back to the table, selecting a score is nice and easy. Now my advice here is to write your own table. I know the AIAG will provide a standard, but they can't know your industry. They can't know how easy it is to reference the severity of a problem. Write your own and try to make it clear and unambiguous, but we have to give the severity a score. It's usually from 1 to 10. So I'm going to give this a severity. In this case, I'm going to give it a severity of 8. I haven't got anything to relate it to, so I can't judge the television industry. I haven't got anything to relate it to. So high scrap rate for me would be quite a serious problem. So I'm going to give it a 7. Then it says, what are the potential causes? Now when we go to the potential causes box, here's something you must never write in the box. And I know in the UK, Rolls-Royce making aero engines for jet airliners, they've told their supply chain this is something you cannot write in your FMEAs, and it's this: you cannot write operator error in the list of potential causes. Operator error. Now then, why do I want you to avoid the phrase operator error? Not because operators don't make mistakes, but typically if you write operator error down, the solution, the control, is very weak, because what we tend to say is we'll train that person. That doesn't fix the problem. That person could be trained and they could take the day off. A temporary person stands in. They might make the mistake now. Or the trained person gets promoted and you forget to train the new person. So operator error and operator training, Rolls-Royce in particular, will not accept operator training as a control, quite rightly, because it then requires the operator to remember that standard and that training. Okay, so what are the potential causes for making the mistake? So drying time, too short. What's the potential cause of making that mistake? Let's put something in the box. So I'm going to say standard, not visual, to the operator. And I'm also going to say, and no tools to measure time. All right. So we've gone drying material. Drying time is critical to quality. The drying time, what's the failure mode? Well, the drying time could be too short. Yeah, so we don't let the plastic dry. What's the failure effect? Well, if we use that in the process, we'll get white marks in the molding. What's the potential cause? Well, the standard is not visual to the operator. In other words, it's buried in a book or it's buried deep in a document somewhere. How likely is this to happen? Now the occurrence, now again, this again has got a scale, the occurrence, and again it's normally 1 to 10. But let me show you the one that I recommend in my book, Drink Tea and Read the Paper. So in Drink Tea and Read the Paper, the rule I use for how likely is it to happen, is it likely to happen once a day, once a week, once a month, once a year. Okay, now I've only give it a 1 to 4 scale. Now of course, sorry, but the other way around, wasn't it? 4, 3, 2, 1. You could go once every 2 years, once every 5 years, once every 10 years if you really want to. Now why have I picked this scale? So it's back to what I'm saying before. This has got to be easy to fill in. One of the reasons FMEAs take forever to fill out is because everybody argues about where we are on this scale. Now what I'm basically asking you to judge is, how often are you going to upset a customer? How often are we going to upset a customer? Are we likely to upset the customer once a day, once a week, once a month, once a year? Now, normally in a conversation, it'd be quite easy to say, well, yeah, we probably wouldn't make that mistake every day, because if we made it a couple of days running, we'd soon realise that the dryer wasn't working properly. But you know, we might say, well, we're likely to make it once a month. If we're not concentrating, if the operator's not concentrating, if we're rushing, you know, and we don't have equipment to tell the operator how dry something is. So even though they're trying to adhere to the rule, there might have been a shift change and they might not know when the material was put in the dryer. So they don't know whether the material is dry or not. So we might make that mistake once a week, we might make that mistake once a month. And the idea is that it becomes very easy to say, yeah, okay, we'll pick a 2. Yes, okay, we'll pick a 3. Now in this case, I'm going to pick a 3. I think if we're not telling people what the standard is, and we don't give them tools to help them to judge how dry the material is, how long it's been in the dryer, I would expect us to make that mistake just by accident once a week. So I'm going to give that a score of, in this case, 3. Let's put that in there. And then it says, what are your controls? What are your planned controls? So if this is a new process, this would be, whoops, spelled that wrong. This would be, what are your planned controls for this? Okay, so we could say, okay, our planned controls, specific, we're going to have a specific drying area. Okay, we are going to have bins with clocks and alarms on. So we're going to make the standard obvious, and we're also going to have so we're going to have a bin with a clock on it, which you can then program, but we're also going to have the standard displayed next to clock. All right, so there's our There's our control, okay? Okay, so there's my control mechanism. Then you've got to ask the question, okay, how likely are we to, it says detect. Now, we don't really want to detect the problem, we want to prevent the problem. How likely are we? And that's why the new standard, which is about error proofing, okay? How likely are we to prevent or detect the problem? Now again, let's look at a current method of determining how likely are we to detect. So let me look at a table that I've downloaded from the internet, a standard that I've downloaded from the internet. Again, this is a car industry example. I've downloaded this straight from Google, and here's the detection and prevention criteria. I mean, look at this. It says if you score 5, that is between a 36 and a 45% chance of detecting the fault. If you score an 8, there is a 66 to 75% chance that you're gonna spot the fault. Now tell me, how the hell are you gonna decide 65 to 75%? How are you gonna decide 45 to 55%? You've got no chance with a table like that. You need to rewrite this. Now I'm gonna show you one that I've rewritten. I don't know how well it relates to the Fmea that we do. I'm going to take a look at it now, but I suggest you write your own and you will see that it relates to the tool I've used. So what I've done is I've said I've got a control mechanism. How good do I think the control mechanism is? So let's take a look at my list. So here it is, look, 1 to 10. We start with 1 and it links in very nicely to the AIAG new rules, which is number 1 is a mistake proofing device is fitted to ensure complete prevention. Okay, it says a mistake proofing device is fitted to alarm out if the input goes out of spec to minimize the defects and isolate the affected part. 3 says TPM routines are in place daily. 4 says TPM routines are in place weekly. 5 says SPC is being used. 6 says visual standards are out at the point of activity for regular audits. Now I would say that's roughly where I am. I'm going to put visual standards out at the point of activity for regular audits. Okay, so then it says operators are trained to do the job correctly. A skilled person will know what to do. TPM is planned yearly. Finally, there's no control at all. Now I think I'm around 6 at this point because I've got visual standards out at the point of activity. So let's go to my table. Now I'm actually going to score it slightly better than 6. I'm going to give it a 5. Why am I going to give it a 5? Well, I've given it a 5 because I have more than just visual standards out at the point of activity. I have a clock with an alarm, so I have a sort of a mistake proofing device. It doesn't tell them that they're making a mistake, however. It tells them they've hit the standard, which is a slightly different thing. If we linked the timer to the lid so that they couldn't lift the lid until the timer timed out, I'd be scoring this as a 1, by the way, because now they can't get at the material until the timing cycle has finished. That would be a 1. But I've got a timer that alarms out. So I think I'm slightly better than a 6. But given that this still relates to the person following the rules, they could cut across all the rules and violate them. I'm going to give this a 5. Okay, and that's where I am. So if we go back to the form now and we look at those 3 scores, we've scored severity, likelihood and detection. So what did we put? I put 7. I've put 5 here. What have I put for likelihood? I've put 3. If I multiply those 3 through, what do I get? I get 105. Now again, key thing, before you start this activity, you have to decide what this number is going to mean. Now bear in mind, by the way, that this was only a 1 to 4 scale. This was a 1 to 10 scale. So what's the worst I could get? 10 times 10 is 100. So 400 was the worst I could get on my scoring system, because I'd only got a 1 to 4 scale here for the likelihood. So 400 is as worse it could be. So what you have to do is decide rules. If you say, I'm above 300, here's how we'll behave. If I'm above 200, here's how I'll behave. If I'm above 100, maybe, here's how I'll behave. So this 105 would either be telling me everything's okay, or it would be telling me, probably, given that I'm towards the bottom of my scale, I'm doing pretty well. You should try and improve it a bit better. And the area I would go to is full mistake proofing with a lock on the lid with the timer. If we do that, this will change to a 1 and this whole number will collapse to 21. Now we have total control. If we think this is bad enough, if we think the severity is bad enough, we might want to take this down to 21. Now what I'm going to do, of course, I'm going to set up the moulding machine with a drying area, with the standards on the bin, with the special timed locks on the bins. That's what I'm going to do next. So what I've done now, I've told everybody in my FMEA what my process looks like, what my potential risks are in terms of making defects and upsetting the customer. So I've told them how important each variable is in my process: times, temperatures, speeds, injection pressures. All of those numbers will all be in my FMEA. And I will say, if they get violated, this is how important they are, and here is how I intend to control them. And now I will design the process with the FMEA for the drying process. I will design the process with password protection for all the programs on the moulding machine, etc. And then when I go live, this thing is going to go live, bang, defect free, making piles and piles of money from day one. And that is the proper way to do an FMEA. That's what FMEAs are for, that to design processes into. Now, of course, will I hold this up to scrutiny? Will I let a team of engineers look over my process design and say, have I forgotten anything? Yes, but it isn't a 3-day FMEA meeting just filling out a form, talking about what scores to have for hours and hours on end with no value whatsoever. This thing makes money. It makes your process go live, bang, from day one, making money. Then let people scrutinize it and let it get it better, even better, in case you've missed anything. But once you're ready, what comes out the other end? Well, what comes out the other end is a control plan. So on the end of this thing, where I'm saying I'm going to use timed locks on the dryers, that's a control technique. That's a control plan right there. In the planned control column, in this column down here, we have a control plan. And if you ever get a problem with your molding process, if you ever get a problem molding the battery cover, what do? You pull up the control plan. What they do is they generate control plans. They generate a control plan that means you go live right first time and make piles of money. They also generate a control plan so that if you get a problem, it's auditable, and your problem solving just takes a few minutes or a few hours, because these things are fantastic if you do them right and you use them for process design. FMEA, the power of getting it right first time. Now, if you'd like to know a little bit more, you'd like to look at my view about FMEA, and you'd like to buy my book, Drink Tea, Read the Paper, you can get it from lulu.com. You can buy the paperback version if you want one in your hand, or now you can get the electronic version for just a few pounds. So all my thoughts about FMEA are in here, plus lots more besides. But even if you don't buy the book, folks, please do FMEA. Please do them properly. Get loads of possible value out of your FMEA and make piles and piles of money.